The S2 paper has 5 to 6 to 7 questions. In this particular paper there are 7 questions. Total mark is 75, and there are two types of question: discrete random variables, probability distribution. There would be binomial distribution sums and probability distribution sums. So one type of sum is discrete random variable sums. The other type of sums is continuous random variable sums. These are general continuous distribution and uniform continuous distribution. So this paper, every S2 paper will have two types of questions: discrete random variable sums and continuous random variable sums. This first one, it is estimated that 4% of people have green eyes. In a random sample of size n, the expected number of people with green eyes is 5. This is a discrete random variable sum, binomial distribution. So this would be, let me use a different color. So this would be, expected value is 5. So Ex is 5. For binomial distribution, the formula for expected value is NP, that is equals to 5. We know that probability of success is 4% of the people have green eyes. Therefore, n into 4% is 0.04 equals to 5. Therefore, n equals to 5 divided by 0.04, and that is going to be 125. The expected number of people with green eyes in a second random sample is 3. So there is a second sum. So expected value this time is 3. Perhaps it's a good idea to use a different random variable, because previously we used x for one sample and this is a different sample. It is wiser to use a different random variable. Therefore, NP this time is equals to 3. Find the standard deviation. Standard deviation means variance. The formula for variance is, we know sigma squared equals to variance of y, and the formula for variance is NPQ. Q means 1 minus p. So if expected value is 3, so NP is 3 and 1 minus p is 4%, that means 0.04. That means 3 into 0.96. That makes it 2.88. But the question was standard deviation, so sigma is square root of 2.88, and the answer is square root of 2.88 is 1.69. That means in 3 significant figure it would be 1.69697. okay, let me write 1.697. to 3 significant figure it would be 1.70. Question number 2, continuous random variable sum, and the interval is given. If the interval is given, it means it's a uniform continuous distribution. We have to write down the PDF. The formula for PDF is PDF equals to 1 by beta minus alpha. That's the formula. This would be fx equals to, so this would be 1 by beta minus alpha, so 6 minus 2 is 4, comma 2 to 6, 0 otherwise. Question number B is the expected value. The formula for the expected value is alpha plus beta by 2. So the expected value would be 2 plus 6 by 2, 8 by 2 is 4. The variance would be variance beta minus alpha whole squared divided by 12. Six minus 2 whole squared divided by 12, that means 6 minus 2 is 4, 4 squared is 16, 16 by 12, 16 by 12 means 4 4s are 16, 4 3s are 12, 4 by 3. D, find the CDF. For finding the CDF, we need to integrate. So D would be CDF equals to integration of fx. Integration of fx is 1 by 4 dx. Let's move on to the next page. Equals to integration of 1 by 4 is 1 by 4x, and we write plus c. Therefore fx equals to, the CDF equals to 1 by 4x plus c. We need to find the value of c, the constant, just like in C1. The sums in S2 that deals with continuous random variable uses the technique of C1. Remember, for cumulative probability, cumulative means total. Total probability is 1. The total probability can be found by adding up all the probability. That means the upper limit is 6. So f6 means from the beginning till 6. That means total probability is 1. So f6 is 1. Always take the upper limit and that would give you 1. We know f upper limit equals to 1. Therefore 1 equals to 1 by 4 6 plus c. So this would be 3 2s are 2 3s are 2 2s are. Therefore c equals to 1 minus 3 by 2. 3 by 2 means 1.5. 1 minus 1.5 is minus half. Therefore fx would be equals to 1 by 4x minus half. Now we have to define it. The definition is fx equals to expression here 1 by 4x minus half, and the limit is from 2 to 6. Now upper, this lower than the lower limit is 0, higher than the upper limit is 1. That's how you define the CDF. The final question, we have to find the probability between 2.3 to 3.4. Probability of 2.3 to 3.4. Now one thing you need to remember, this is continuous. For continuous, how do we write this? We write this as probability x is less than 3.4. We also did this in normal distribution in S1, where you have to subtract it like this. And remember, cumulative, this means f 3.4 and this means f 2.3. All we have to do is subtract. So this is f CDF. If we put 3.4 here, it would be 1 by 4 3.4 minus half, and this would be 1 by 4 2.3 minus half. So the answer would be equal to, so 1 by 4 into 3.4 is 3.4 by 4 minus half, that is 0.5, that would be 0.35, minus 1 by 4 into 2.3 is 2.3 by 4 minus half, that means 0.5, that will be 0.075, .35 minus 0.075 is 0.275. The random variable x is the number of misprints per page in the first draft of a novel. So per page number of misprints, obviously it's a Poisson distribution, and they have mentioned it that it's a Poisson distribution. So question number A, state two conditions. Always write down the same answer no matter how many conditions they want. So events occur. Event is number of misprints. Misprints occur singly, independently, and at a constant rate. Question number B. The number of misprints per page has a Poisson distribution with mean 2.5. So per page, remember the interval is per page, so mean is 2.5. So we can define the distribution: number of events, number of misprints, and the unit is per page, and the distribution is going to be Poisson 2.5. This is for per page. If this per page changes, then lambda would change and the distribution random variable would change. The randomly chosen page has no misprints, so we have to find the probability of x equals to 0. We have to look up the table. So the table would be, this is the Poisson distribution. Value of lambda is 2.5. 2.5 is this column, and 0, x equal to 0 and x is less than or equal to 0 is the same thing. 0.0821. 0.0821. For question number C, the total number of misprints on two randomly chosen pages. Two randomly chosen pages means that we have to change the interval. So now we have y, number of misprints per two page. We have to change the random variable to y. So the Poisson distribution now, previously it was 2.5 for one page. For two page it would be 2.5 into 2, which is 5. And the probability we have to find, probability is usually given by more than, less than, exactly like that. So probability is more than 7 misprints. So y is greater than 7. In discrete distribution, greater than 7 means greater than or equal to 8. If something is more than 7, that means it is definitely going to be 8. The next one is 8. So y is greater than or equal to 8. That means 1 minus probability y is less than or equals to 7. So let me do it here. So 1 minus, if you look up the table, now we have to look up 5. Lambda, the value of lambda has changed. Remember, this is 5, and we have to look at x is less than or equal to 7. X is less than or equal to 7 is this one, 0.8666. 0.8666. So let's bring out the calculator. 1 minus 0.8666. That makes it 0.1334. Next question. The first chapter contains 20 pages. Now we have a new distribution where there are 20 page interval. So again we have to change the random variable. First we used x, then we used y. We cannot use z because the normal distribution uses the z-score z. We can use a. So a equals to number of misprints per 20 pages. So for one page it was 2.5. For 20 pages it would definitely be 50. Let's check. 2.5 into 20, that's 50. That means it's not in the table. If lambda is more than 10, we have to go to the approximation, and one way of doing that approximation is the normal approximation. To do an approximation is to convert the distribution completely into a different distribution so that we can go on with the sum. Now what is the sum? The sum is we have to find the probability less than 40. So the sum that we have to do, we have to find probability of A is less than 40, fewer misprints, less than 40 misprints. That means we cannot use this distribution because in the table lambda is up to 10. Whenever we have to go beyond 10 for Poisson distribution, we have to convert this useless distribution into a new distribution. So what distribution do we use? We use the normal distribution as an approximation. Using normal approximation for Poisson distribution, for finding the normal distribution we need two values. The parameters for normal distribution, I'm just writing the letter x as a convention. So mean and variance, we need these two. So the formula says mu for the normal distribution conversion from Poisson is going to be lambda, which is 50. This is lambda. And sigma square is going to be lambda as well, again 50. So what alphabet can we use? We cannot use B because B is for binomial. We can use C. The letter C is free. So normal approximation, mu is 50 and sigma square is also 50. That means we have to find the probability using this. Now we need to do continuity correction. So A is less than 40. It would be, we have to make it less than or equals to. C is less than or equals to 39. Less than 40 means 39. It has to be equal to for continuity correction. That means if it is 39 and if we want less than, we have to start from here a bit earlier for the continuity correction. That makes it 40, 39.5, just 0.5 backwards. That makes it 39.5. That's the continuity correction. So C is less than equal to 39.5. Now the equal to sign doesn't matter at all. Now we have converted the discrete into the continuous using the continuity correction, because Poisson distribution was after all discrete. Normal distribution is continuous. Let's do the z-score. Therefore probability of z is less than, now I'm not going to use the equal to sign at all, it's not needed. 39.5 minus mean is 50 and standard deviation is square root of sigma. This is equals to probability of z is less than 39.5 minus 50 divided by square root of 50 equals to minus 1.485. Minus 1.485. In order to find the probability, we have to make this positive, so the inequality will be reversed, S1 rule. So less than would become greater than 1.485. Now we have to look up the table, but again this is greater than, we have to make it less than. 1 minus probability of z is less than 1.485. Now we are ready to look up the normal distribution table. 1.485 is around this column. 1.485, 1.485 means 1.49. That would be 0.9319. 1 minus 0.9319. If we subtract this from 1, that would be 1 minus 0.9319. That would be 0.0681. 0.0681. These are common terms that needs to be memorized. First of all, what is a sampling unit? A sampling unit is an individual item in a sampling frame. Remember, there are keywords to be memorized, so this is one of them. So you need to memorize this. Question number B. What's a sampling frame? A sampling frame is a list. A list of items in a sample. Next, question number C is a sampling distribution. Now you need to memorize this definition verbatim from the book, but one answer can be all possible samples are chosen from the population. This is pretty obvious. You choose all the possible samples from the population. Now when you take that sample and you find some statistic, this statistic can be the mean, the median, or anything. The statistic that you calculate, so the values of the statistic which is calculated from the sample. Statistic is any calculation made from the sample, like mean, mode, median. So the values of the statistic and their respective probabilities make up the sampling distribution. So what does that mean? This means if you have something like a table that we did in S1, a general probability distribution, this is the random variable and this is the probability. So the random variables are given here, suppose 0, 1, 2, 3, 4, 5, 6, 7, and each of their probabilities here. So this thing is called a probability distribution. Now if this random variable is some sort of a calculation made from a sample, that random variable would be a statistic, and each of the probability would be the statistic of each of the probability. So this distribution, this probability distribution, would be a sampling distribution. For this sum, in a manufacturing process, 2% of the articles produced are defective. A batch of 200 articles is selected. Giving a justification for your choice, use a suitable approximation. Obviously they're talking about percentage, so this is a binomial distribution. This is a binomial distribution, and the condition for using a approximation for a binomial distribution is when n is large and p is small. So n is the batch, so the batch n is large and the probability of being defective, the chance of defective items, articles, defective probability of defective is p is small. That's it. But try to write your answer in context. So n is large, p is small. Oh, the sum is not done yet. We have to estimate the probability. So the condition was this, giving a justification. So this is the justification. Now we have to find the probability. Before we find the probability, we always have to define it. So x equals to number of successes. So number of defective articles. Defective articles. So the distribution would be n is 200 and p is 2%, 0.02. So we have to find the probability of exactly 5 defective articles. X equals to 5. But this distribution cannot be used, as we know that in the table we don't have n equals to 200, it's up to 50. For that reason the table cannot be used, so this distribution is useless for us. So in order to do that, we have to use an approximation. We have to use Poisson approximation, because the first target to do is see whether binomial can be converted to Poisson. If it cannot be converted to Poisson, meaning if lambda is more than 10, then we have to go directly to normal approximation. Now 200 into 0.02, 200 into 0.02 is 4. That means lambda equals to 4. We can use the Poisson approximation. Using Poisson approximation, We never use the Poisson approximation for Poisson. Why would we convert Poisson to Poisson? Because it's already Poisson. We only use it for binomial. So we need the value of lambda. Lambda equals to expected value. Expected value is NP. N is 200. P is 0.02. That makes it 4. So we change the, we don't have to define it because the definition is here. We just have to name the random variable. So it's y and the distribution is 4. Lambda equals to 4. So we have to find the probability exactly 5. Exactly 5 means this time it would be y equals to 5. So for discrete, this means probability of y is less than or equals to 5 minus probability of y is less than or equals to 4, and we have to look up the table where lambda equals to 4. Lambda equals to 4 is here, and we have to find x is less than or equals to 5. So less than or equals to 5 is 0.7851. 0.7851 minus less than or equals to 4 is going to be 0.6288. 0.6288. Now all we need to do is subtract 0.7851 minus 0.6288, and this would be 0.1563. 0.1563. The next question is estimate the probability there are less than 5 defective. Less than 5 defective probability of x is less than 5 defective, again using Poisson approximation. Remember, we cannot write x because the binomial distribution is defined by x, and the binomial distribution is useless because n is large, p is small. We have to do the Poisson distribution. So probability of y is less than 5. That means probability of y is less than or equals to 4. We can just look up the table. I think we put the value here. That is 0.6288. 0.6288 is the answer. Question number 6 is continuous general distribution, and we have to use the C1 rules of integration and differentiation for this. This is not an S2 type of sum. In S2 there is hardly any math. We just look up the table and lift the number. Here we have to do some math. Show the constant. The rule for constant is integrating fx. That's the formula. Integration over the whole limit fx dx would give you 1. So integration, the limit is 0 to 2, fx dx equals to 1. So integrating 0 to 2, fx is k 4x minus x cubed dx equals to 1. This means if we integrate this, that would be let me write more simplified form. K into 4x is 4kx minus k into x cubed is kx cubed dx equals to 1. So if you integrate this, this would be 4k x squared by 2 minus k x to the power 4 by 4 0 to 2 equals to 1. This would be 2 to the 4. So that means 2k, if I put the limit here, upper limit here, 2 squared minus k by 4 2 to the power 4 minus, if I put 0 here, it would be 0 equals to 1. That means if we simplify this, it would be 4 into 2 is 8k minus 2 to the power 4 is 16. 16 by 4 is 4k equals to 1. Therefore 4k equals to 1 and k equals to 1 by 4 shown. Next question, find the expected value. The formula for the expected value is limit x fx dx. So question number B would be expected value, limit is 0 to 2 x fx dx. So 0 to 2 x. Now fx is k into 4x minus x cubed. K is 1 by 4. This is 4x minus x cubed dx. Now all we have to do is integrate 0 to 2. If you multiply 1 by 4 into 4, this would be 1. If you multiply x into x, this would be x squared, minus if you multiply 1 by 4 into here, this would be 1 by 4, and x into x cube would be x to the power 4. That means if we integrate, x squared would be x cubed by 3 minus 1 by 4, x to the power 4 is x to the power 5 by 5, and this would be 0 to 2. So that would be, if you put here 2, this would be 2 cubed by 3 minus this would be 1 by 20, this would be 2 to the power 5, minus if you put 0 here and 0 here, it would be 0 completely. So that means 8 by 3 minus 2 to the power 5 is 32, 32 by 20, and the answer would be 8 by 3 minus 32 by 20, 32 by 20. That is 16 by 15. The next question is, you have to find the mode. Now for mode you need the diagram. If you have the sketch of fx, you can just look at it and know which data has the highest frequency. But if you don't have that, you have to remember mode means turning point. Turning point is the highest frequency, so at the turning point gradient is 0. Using that rule you have to find the mode. So the rule for the mode would be at mode f prime x equals to 0. So the derivative is going to be, it's going to be k, and constant is constant, 4x is going to be 4, and x cube is going to be 3x squared equals to 0. That's the derivative. You can keep the constant outside the bracket. If you send the k to the other side, it becomes 0. We don't have to put the value of 1 by 4 because it becomes 0 anyway. So 4 minus 3x squared equals to 0. Therefore 3x squared equals to 4. That means x squared is 4 by 3. Therefore x equals to plus minus square root of 4 by 3. Which one to take? Remember, the limit is from 0 to 2. That means it is going to be the positive value. So answer mode is square root of 4 by 3, which is square root of 4 by 3. I'm going to give a bracket because we want square root on both of 4 and 3. This would be 1.155. 1.155. The next question is, we have to find the median. Now in order to find the median, we need the CDF. The rule for the median is that you have to remember fx is the CDF, and for median CDF is equals to 0.5. Remember, for median FQ2 is 0.5. That's how you find the medians. For that we need to find the CDF. So let's find the CDF. For that, let's okay, so this one is question number D, the median of x. So we have to integrate this. For finding the CDF, we have to integrate this expression. So question number D, fx equals to integration of fx dx. So integration of fx is k, which is 1 by 4, and this is 4x minus x cubed dx. That means we can keep the 1 by 4 here, and the integration of this is 4 x squared by 2 minus integration of x cube is x to the power 4 by 4, and we have a plus c here. If we cancel this off, this 2 and this 2 cancels, so this would be 1 by 4 2x squared minus x to the power 4 by 4 plus c. Again, if you multiply with 1 by 4, this would be 1 by 2x squared minus 1 by 16 x to the power 4 plus c. So you know that the upper limit is going to give 1. We know f upper limit is 2 equals to 1, therefore 1 equals to half 2 squared minus 1 by 16 2 to the power 4 plus c. So 2 squared is 4, 4 by 2 is 2 minus 2 to the power 4 is 16, 16 by 16 is 1 plus c, therefore 2 minus 1 is 1, so 1 minus 1, c equals to 0. So fx is going to be half x squared minus 1 by 16 x to the power 4, because c is 0. Now for finding the median, we know fx is going to be equals to half. By the question, f median equals to 0.5. That means half x squared minus 1 by 16 x to the power 4 equals to 0.5. Let's multiply both sides with 16 because this is the largest downstairs. So 16 into half is going to be 8 x squared minus 16 by 16 is 1 x to the power 4. 16 into 0.5 is again 8. If we rearrange this, it would be minus x to the power 4 plus 8x squared minus 8 equal to 0. If you multiply this, it would be x to the power 4 minus 8x squared plus 8 equal to 0. Now how to solve this? This is a quartic equation, x to the power 4. Well, remember this, one way of solving this is let x squared be a. If you consider x squared to be a, then x to the power 4 is x squared whole squared, that means a squared minus x squared is a plus this equal to 0. So now we can do this, we can just solve this. This can be solved using the quadratic equation, so we can write therefore a equals to minus b plus minus root over b squared minus 4ac. Do not write in this area in the exam because it's for the examiners. Divided by twice a, so twice a, that makes it 8 plus minus root over minus 8 whole square is 64, 64 minus 4 8 is 32, so 64 minus 32 is 32. So this is 32 divided by 2. If we simplify this, this would be 8 by 2 plus minus 32 is 16 2 is 32, so 16 outside the square root is 4, 4 root 2 by 2. If you cancel this, 2 to the 4, if you cancel this, 2 4 is 8, so 4 plus minus 2 root 2, so this is a. Now we need the value of x, so a is x squared, therefore x squared equals to 4 plus minus 2 root 2. So let's take the positive value for the first one, for plus. So for x square equals to 4 plus 2 root 2, we are going to get x equals to, I'm going to take the positive value because the limit is 0 to 2. So let's do this. 4 plus 2 root 2, it's going to be 6 point something. Square root of that is 2.613. 2.613. So this is obviously not going to work, even the positive value, because we need from 0 to 2. So I'm going to take the other one. So let me do it here. Therefore x square equals to 4 minus 2 root 2. Now I'm going to take the negative one. That means 4 minus 2 root 2 is 1.17. Now this is going to work. So square root of, therefore x equals to square root of that. Answer is going to be 1.082. 1.082. Now this can be the median because the limit is between 0 to 2. So this is done. The next question, comment on the skewness. So we have the median and we have the expected value, which means the mean. So we can compare the mean and the median to say whether it is positively skewed or negative skewed. So the median is 1.08. Median is 1.08 and the mean was 16 by 15. 16 by 15 means 16 divided by 15 means 1.07. Pretty close. 1.07. 1.07. Now if you might say that this is symmetric, alright, but you might also say since mean is less than median, it is negatively skewed. That's it. Now let me just draw a mark here. Okay. Now the final question is the sketch. Now there is very little space here. Let me try to do the sketch here. So sketch fx. So this is our fx. So we need an x-axis and we need a y-axis. We put x equals to this, then we put y equals to this to see what the picture is going to be. So we already know this is a curve, so it is going to be something like part of an NU, and we know the x-axis, y-axis value. So let's try to sketch this. So the x-axis is going to be this, label it x, and the y-axis is going to be fx. So the limit is 0 to 2. So this is the expression. Since it's copied here, let me just, this is fx. Let me use it for a while instead of going back and forth. So this is fx. So when I put x equal to 0, it will be 0 minus 0. The whole thing would be 0. So what would happen? This would be 0 here. When I put x equals to 2, this would be 4 to the 8 minus 2 cubed 8. 8 minus 8 is 0. Again it would be 0. It would be here. So in the meantime, we know it's going to be a shape of a curve, so we can make it like this. But this would not be wise because in the previous sum we know it is negatively skewed. So the shape of the negatively skewed helps. It's a good idea to give the shape like this. So towards the negative skewness. So a drugs company claims that 75% of patients suffering from depression recover when treated with a new drug. A random sample of 10 patients with depression is taken from a doctor's records. Okay, write down the obviously percentage means binomial distribution. Binomial distribution. And now we have to write down the definition. So this is going to be x equals to number of successes, so number of recoveries, and the distribution is going to be n is 10 and p is 0.75. Done. Next question was, find the probability that the treatment will be successful in exactly 6 patients. So B is probability of x equals to 6. Now in the table we don't have 0.75, in the table we have up to 5. So here we have up to 0.5. So the probability given in the question was up to 0.75. So we cannot look up the table. So whenever you cannot look up the table, you can use the formula. So the formula is NC A, so this 6 is A, so it would be N is 10, CA is 6, then 1 minus P is 0.75 to the power N minus A, which is 4, so P is 0.75 to the power 6. So let's calculate this. This is going to be 10 C 6, which is 210. Then we have 1 minus 0.75, this is 0.25, so 0.25 to the power 4, this is this, multiplied by 0.75 to the power 6, this is this. Now we can multiply this with 210, and the answer is 0.14599. So let me just cut this, 0.14599. Okay, now the doctor believes that the claim is incorrect. Okay, incorrect means 75% is wrong. So without, we can just write this down. So H naught is P equals to 0.75. Before reading the question we can write this down. Okay, so the doctor believes that the claim is incorrect and the percentage who will recover is lower. Lower means H1 is going to be less than 0.75. This can be written even before reading the question. Okay, from her records she took a random sample of 20 patients. Remember, number of patients was n, so the distribution now has changed from x to y. So 20 patients, probability of success is same, so this is different now, who had been treated with the new drug. So number of recovery is 13 recovery, so that is the random variable, so that we have to test. So remember, the random variable is always going to be matching with the H1, so less than, it means y has to be less than or equals to 13. That's how it works. Okay, stating your hypothesis clearly test at the 5% level of, that is the threshold of rejecting H naught, 5%. If this probability is 5%, we have to reject H naught and the doctor's belief. Okay, now first of all, we cannot use the table because 0.75 is not in the table, although n is not large and p is not small, so we cannot do the approximation either. So this is a problem. We cannot use the table because in the table this is not there. We cannot use the approximation. So the only thing left to do is the PDF, the formula, but it will be very long because y is less than or equals to 13. That's a very long calculation. 0, 1, 2, 3, 4. It's huge. So in this situation, there is a special thing that we can do. We can switch the probability of success. How can this be done? So let me explain. If you take the success as the other one, meaning instead of taking this as the success, if you take the other one, so that means 1 minus 0.75, which is 0.25. So if you reverse the sum completely, meaning not recovering, so if you make the success to be people who do not recover, the same thing will happen, no problem at all. So let me explain here. So if we write x and y has been done, A equals to number of people who do not recover. So we are taking the failure as the new p. So p is going to be 1 minus 0.75, meaning 0.25. So the distribution is going to be n is 20, now p is 0.25. Okay, now in that case, if you think about it, previously it was less than or equal to 13. So what does that mean? If less than or equal to 13 people recover, so there are 20 people in the sample, so if 13 people recovers, that means 7 people do not recover. If 12 people recover, that means 8 people do not recover. If 11 people recover, that means 9 people do not recover. If 10 people recover, that means 10 people do not recover. In otherwise, what's happening? Y is less than or equals to 13. So this means y is less than or equals to 13, meaning 13 or less people do not recover. And here, what's happening? A is greater than or equals to 7. So this thing can be converted to this. The probability can be switched as well. So we can have the test of the hypothesis by switching the distribution altogether. So what we can write is probability of A is greater than or equal to 7. So now using the distribution table, because both 20 and 0.25 is in the table, we can, this is a rather switching the distribution type of a technique. Instead of using the approximation, instead of using the PDF, this is just a special irregular way of doing it whenever the probability is more than 50%. So this, by this discrete distribution, we can write probability of A is less than or equals to 6. Then we can look up the table. Now we need n equals to 20, so 10, 12, 20. Great, n equals to 20. Now we need p equals to 0.25. So this column is 0.25. This column is 0.25. So for this column, what we need is the value of less than or equals to 6. That means 0.7858. So if we subtract this, 1 minus 0.7858, that is 0.2142. Now 0.2142 is, if you multiply by 100, is 21%. That means it is not within 5%, it is more than 5%. So not significant. If it is not significant, accept H0. So if you accept H0, so the claim was not right. You have to write down the answer in context. What was the claim? The claim that recovery chance is lower. So that was the doctor's belief. The doctors believe is not correct. That's it. So the next question. Okay, now what we have to do, from a sample of size 20, find the greatest number. Remember, whenever they say greatest number, they're actually talking about the random variable. Remember, whenever they're talking about the greatest number in a hypothesis test, they're just doing the reverse, the opposite, meaning the random variable. The random variable in a hypothesis test is called the critical value. So anyway, so we need to recover for this test in part C. So if you have to do, let's do question number D. Again, H0 is P equals to 0.75, H1 P is less than 0.75. This time we don't know what the random variable is, we know the probability known as the significant level. For this particular sum, the significant level is 1%, that is the probability. So that means if the random variable was known, so the critical value, so let the random variable x is less than or equals to the critical value, which is going to be, by the way, just like before, let's take this directly. So let's take the distribution directly because the sum is the same. So I'm going to take A directly. So the probability of A is less than or equals to, by matching this. Now this thing is unknown, critical value. This is the critical value. This critical value is unknown. So this probability has 1%, 0.01. So we have to look up the table. So let's look up the table for the distribution where n equals to 20, p equals to 0.25. So n equals to 20, p equals to 0.25, so we have to look for this probability which is closer to 0.01. 0.01, this is what we have, 0.02, and this is what we have, 0.00. so which one is closest? So okay, let's backtrack. Let's backtrack and do this from the beginning. So what we have to do here is, okay, so sample size is 20. That means, remove this. Okay, so this is the null hypothesis, this is the alternate hypothesis, and since 20 sample, so the distribution is going to be y binomial n equals to 20, p equals to 0.75. So by this distribution, the random variable that we have to find, so that greatest random variable that has to be y is by this less than or equals to c, and the probability now is given 0.01. Since we cannot do this, so what we have to do is we have to convert this just like before. So if you convert this to the different distribution a, so this would be 20, this would be 0.25. So just like before, so this was 20, this was less than or equal to, this would be greater than or equal to. So this was a, this is less than or equal to, this would be greater than or equal to. 20 minus 13 is 7, so 20 minus c is going to be 0.01, just like before. Now we have to find this portion. Now this portion is a bit cumbersome, so let's use one alphabet. Let 20 minus c equals to small letter a. That means probability of a is greater than or equals to a equals to 0.01. Now by discrete rule, if you want to find less than or equal to from the table, this is going to be 1 minus probability of a is less than or equal to, this will be 1 less, a minus 1 equals to 0.01. Let me do it here. That means 1 minus that is going to be probability of a is less than or equals to a minus 1 equals to 0.99. So now we have to find what is the closest equivalent. So this is 20 and this is 0.25. So the closest to 0.99 is here, 0.999. This is more. So this is 0.996 and this is 0.986. The closest is this one, 0.9961, because this is 61 more than 0.99 and this is a bit less, so this is the closest, so 10. So a, this value is going to be 10, so therefore this value a minus 1 is equals to 10, so that makes it a equals to 11. So 20 minus c is equals to 11, therefore c equals to 20 minus 11 is going to be 9. So that is the greatest value. So the greatest value is 9.